let's go. The internet doesn't need to see my blind. Okay, Taylor, the ball rolling across the floor 2.5 meters per second. Vector or scalar? This is a scalar. To make it a vector, I'd have to say east or west or something like that. It's just rolling. We don't know where it's rolling. All right, B. John is pushing a crate 250 newtons to the west. Vector or scalar?
Vector.
Vector. What's the opposite of that?
250 newtons to 50.
Matt, a sound has an intensity of 50 decibels. Vector or scalar? Scalar. Sam, a train travels northwest at 115 kilometers per hour. Vector. What's the opposite? If you need a diagram here, there's northwest, right? So the opposite would be southeast.
Yes, that'd be negative.
Ooh. Oh, I like it. We'll leave negative vectors right now, but maybe that is true, right? So that would be like you're facing northwest, and instead of walking forward, you're walking backwards. Yeah, it's the same thing.
Well, if it's a train, then
So here you're off. How can I help? Go ahead. Yeah.
So 700 meters at a bearing of 120. I actually wrote, I didn't do the bearings. So.
Oh. I'm going to call this a vector. How'd you write this line?
Well, I wrote 700 meters east 30 degrees north.
Not north.
So.
Right, because you're starting 0, 90, 120, right? So it's east 30 degrees south. Okay, that said, you're not getting out of this one. What is the opposite of that going to be? We do east 30 degrees south. What do we look for?
West 30 degrees.
West 30 degrees north. So this is 700 meters. Or if you, whoops, I should say west, right? Or if you want to say like Robin, say negative 700. Just for that, I'm going to make sure, please only use positive directions, I'm going to say in the future.
it's easier to just put a negative in front of it and leave it as is.
You're a computer scientist, I like negatives. There we go. Read your off the box of the weight of 84 newtons.
Scalar.
Scalar. Now, I got in a fight with this before, okay? Weight and mass and all that sort of stuff.
We just talked about that, didn't we?
We did. So that is what Mr. Lacey agrees with me then?
Well, wait, that's fine, because it's a force.
That's all I was saying. Keep going. Vector scalar. Yeah. This is scalar. Even though it's a negative, it isn't like the direction, like the temperature is not a direction, right? It's just a temperature. Finally, go ahead. 120 kilometers per hour. Now again, I shouldn't put down the negative here because it's right. All you're thinking you want to get back to 0. That's all you're thinking. If you add them together, so if one's a positive, one's a negative, we'll add to 0. So that I shouldn't, say that. Okay. We're good. Someone making sense? Yes. Good. No comment means keep going. Yes.
Why did you subtract 9 degrees from 9?
Oh, for this here, you mean? Because the bearing starts at 0 here. So if you want to get to 120, there's 90.
Yes.
Right, and then plus another 30 gets to 120.
Oh.
Right, you know what I mean? It's like 0, 90, yeah. 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 So that's the opposite, right? That's adding 180 or subtracting opposite. Okay, good. All right. Sorry to put you physics students through this. Hopefully the people who aren't in physics are hopefully getting something out of this lesson. Okay, but those who aren't in physics, I apologize. Today's going to be tough. Example 4. Says, name all the total vectors in the diagram. Sally, your diagram is awful. This is supposed to be a regular hexagon? What's that supposed to be? Just go with me, okay?
I can see what you're sketching in.
That's supposed to be a regular hexagon. It's supposed to be. Now, if you have not been in my class before, this is an unfortunate truth, okay? I cannot draw a triangle to save my life, and I'm not kidding. I'm not playing this up. I'm really very poor. So please go with what's actually like the dimensions that are written. Okay, like I draw triangles like this. Okay, and I'm not kidding. Like I'm not kidding. Okay, so please just go by the dimensions that are on the number picture. Read, am I exaggerating?
No.
Maybe
Well,
slightly.
I was doing that in physics class and I drew a diagram today and everyone was like, oh, what's that? What's that box thing? What's that? Oh, that's not a box thing, that's a ceiling. Yeah. So I feel simple.
Okay, that's a regular hexagon that's supposed to be. What does that mean? What does a regular hexagon mean? All sides the same. What else does it mean?
All these sides are the same angle.
Right on. Okay, so that's the other hint, the opposite of saying. So I want you to list all the equivalent vectors in the diagram, please. Okay, pause. We'll do this fast. That should say. Okay, Brianna, can I get two vectors that are equivalent, please? AB equals ED. Wonderful. Nick, can I get another pair of vectors, please?
BF equals CD.
BF equals CE. Good. Good. Courtney, can I get another pair of vectors, please?
FA equals BC.
FA equals BC.
Why aren't you drawing the arrows and the lines in front? Above the words, or the letters.
Technically, they both mean the same thing. I probably should, but that means the same thing with the line over top.
Oh, okay.
It means the same thing.
It's a lot easier to just
Oh,
I
please
drew
don't draw.
top hats on all.
Okay, are there any more? Are there any more? Should we at least one more set? Anything else? Yeah, go ahead.
EF and C.
Yeah, C. And plus all the opposites, okay. EF equals CB.
What about FD equals EC?
F? Yeah, we got that. I'm going to say also plus opposites, right?
Well, could we do that on our test?
So on a test for the sign, would you want to write down?
To be honest, no, because you won't get asked this question on test for science.
Oh, okay.
Like the way calculus goes, I told you this before, the first few lessons are just making you feel good about the unit, and then all of a sudden, it happens. Right? I'm not kidding, it's really what happens. I wish it was another way, right? But you guys are all going to yawn through this lesson and say, this is so easy, I love vectors. And then all of a sudden, yeah. So I hate to be honest, that's it though. Will this make sense though? This concept makes sense? Yes? We're good? Oh, we're good? Okay, here we go. One more example. I think that's it, and we're done. What time is it?
It's a half an hour. Take a breather.
Example 4.
Fine.
5, as I meant clearly. Example 5 says, the diagram shows a rectangular prism. Now I have to say this because I mentioned my diagrams are not good. The diagram shows a rectangular prism. The nice thing about this is very soon we're going to have our iPad set up and we'll be able to see the stuff in 3D very easily. Okay?
Really cool.
It is very cool.
John, are you going to use an iPad? Or are you going to, like, your body's going to combust when you're touching off the phone?
No, I'm not going to say it because I don't want to solve it. Let me wait until the recording's over and I'll say how I feel. That's that. Okay, so this is a three-dimensional image. Rectangular.
This is going to be hard for me to
Okay, I want you guys to do this for me. I'll be able to solve this one, no problem. A is going to say, state one equivalent vector to each.
I start with the front face or the back?
What's that?
How do you draw draw 3D shape.
You put two rectangles.
And then connect the dots.
You have to make it
Just make it one line up and overlap.
Look at that, there's something really three-dimensional.
That's striking. Mine's gonna drink.
There we go, B. Says, if you know what I might do after this, actually, just to make, maybe I'll do a Spider-Man question from grade 11, just to get 3D back. Because it should look a lot like the grade 11, but it's the same as this in grade 11. I'm going to hit pause here, or stop.